Okay. So in the last session, we cover about the financial mathematics. So in financial mathematics, we cover the present value and a future value, right? So we calculate, so as I said that if you want to calculate present value or future value, you require three things that I mentioned in the previous session. So in order to calculate future value or present value, we need uh, three things. We need three things. We need cash flows, all right? We need rate of interest, rate, we call it discounts rate, we call it a required rate of return, we call it interest rates, we call it opportunity rate or opportunity cost of capital or cost of capital. Different names, but main idea is the rate, all right? And the third thing we required is a time, right? So in this topic 3, as I said, you're gonna learn these three things one by one. So which means you're gonna calculate present value, future value using cash flows. That's we covered in the previous session. So we have 4 kinds of cash flows. One is a single amount. Second one is annuity, periodic equal payments. Third one is a perpetuity, unlimited cash flows. And the fourth one is the mixed stream, right? So using this different kinds of I guess we finished all, right? We finished all the cash flows in the last session. Yes or no? Say something. We finished all, right? We finished single amounts. We finished annuity. We finish perpetuity and mixed stream. I guess we also finished mixed stream too. So let me check. Yes, we finish all. Okay. So we finish all these kinds of cash flows. So that was a last lecture, right? So that was the last lecture. So now in today's lecture, we're gonna cover calculate future value and present value or calculate cash flows using rate, right? Or we have to calculate rates using future value and present value. I guess like we calculate cash flows using present value, which means PV divided by 1 plus PV 1 plus R. So using PV, we are calculating cash flows, or FV, we are calculating cash flows, all right? That was the cash flow part, right? That was the last lecture, right? So in this lecture, we will find out rate. We will find out rate using maybe present value or future value, all right? And time with cash flows. So using this information, we're gonna calculate a rate. That's the main ideas for this session, is to estimate the rates using using maybe present value or future value, whatever. So that's the ideas for today's session. So let's start with the session. So topic 3. So what we're gonna study is a This is number 2. So we're going to study about rate. You can call it rate, or you can call it interest rates, anything you want to call it, right? So now, remember, there are two types of rates, two types of interest rates, right? One is a nominal interest rate. One is a nominal interest rate, all right? And second one is a effective annual rate. Effective annual rate. Right. One more thing, I'm also recording this session, and later on I will send you the recorded file. So if you missed any information, or if you forgot to write any information, so you can watch this video again, right? Okay. So nominal interest rate and effective annual rate. So what is nominal and effective? So remember, so let me take I forgot to take your attendance, so I'm taking a picture. Okay, so what is nominal interest rate? Remember, nominal interest rate is the rate which is normally charged by bank. For example, we go to bank to borrow money, right? So when we go to bank to borrow money, so the first questions that we ask that how much rate of interest you gonna charge, and bank offer us interest rate, whatever is interest rate bank is decided. So let's say bank is offering 10% interest rates to borrow money, right? So idea is nominal interest rate is the rates that bank charged, right? Bank charged. Or in other words, lender earn that, or borrower pay that, right? So this is called a nominal interest rate, right? So other definition of nominal interest rate is nominal interest rate is a constant means fixed, right? Constant rate which is offered or paid by lender, because lender is offering money, or borrower is paying, right? So it's a constant rate which is offered by lender, right, or paid by borrower. Remember, it's a constant, right? It's a constant, less likely to change. So whenever we go to bank, and when we see sometime outside the bank, they will say that we are offering 5.6% interest rate for deposit. So that interest rate called nominal interest rates, right? Now, what is effective annual rates. Effective annual rates is the rates that we actually paid or received. Actually, if bank is offering 10%, so it doesn't mean that we are actually paying or receiving 10%. All right? Why like this? So let me give you example. We also call it real interest rate. It also have another name. We also call it effective annual rates, EAR, or real interest rate. Right? Real interest rate. So it has a two name. You can call it either EAR, you can call it either RIR. But EAR from corporate finance point of view, we call it EAR. But from the, if you study any subjects related to bank or finance, then we more call it about real interest rate. Maybe you study microeconomics before. In microeconomics, we also use this rate of interest frequently. So this is called real, but same ideas, effective or real, same thing. Now, as I said, nominal interest rate is the rate that the bank offer us, right, to earn or to pay. But effective is actually we are receiving or paying, not the 10%. 10% it looks, but in reality is not a 10%. So let me give an example here. For example, you deposit money, you deposit $5,000 in a bank for 1 year. And bank says that we are offering you 15%. So means you're gonna earn 15% interest if you deposit money in bank for 1 year, all right? Now, in other words, what does it mean? What does it mean? It means your money will increase by 15%. That's the meaning of this, right? In simple words, we can say that if you deposit $5,000 in bank, so this $5,000 will increase by 15% every year. That's very simple explanation of depositing $5,000 for 1 year at 50%, all right? Okay, so now this 15%, it's your nominal interest rate. This is NIR here, NIR, which is 15%. Now, the question is, do you think your money actually increasing by 15%? The answer is no. Your money is not actually increasing by 15%. Why? The reason is inflation. Inflation rate. What does it mean, inflation? Inflation means the rate which decrease the value of money. Decrease the value of money, right? So your money you deposit in bank, your money increased by 15%, and there is an inflation in market. For example, inflation is 4%. So what does it mean? Value of money will decrease by 4%. So what does it mean? Your net money increased by 11%, right? Net increase is 11%. So increase by 15, decrease by 14, so net increase is 11. So this 11 is an example of EAR. That's the meaning of EAR. Actually, not a constant or fixed. So this is constant and fixed, which is offered by bank. And this 11% is actually you are receiving. That's the meaning of EAR. Understand? Yes or no? Did you understand the meaning of EAR? Why EAR is not same as NIR? Make sure you understand this one, because I'm going to ask this type of question in your exam. What is the major difference between NIR and EAR? So by showing the examples, you have to explain to me. All right. So now we will not calculate here an NIR. We're not going to learn how to calculate NIR. All right. Because this NIR normally decided by central bank or state bank, like as in Vietnam. If you study any subjects about the banks or banking and finance, then you're going to understand how banks decide this NIR. Many factors. So normally we call it monetary policy. Bank normally central bank or state banks, they make a monetary policies, and as per the monetary policies, in monetary policies, bank decide what rate of interest other banks gonna charge. So let's say I'm saying 10%, right? Here 10%. So this 10% that bank is charging from us, this 10% is not idea of the bank. This 10% is the idea of state bank or central bank. They really control the rate of interest, right? So make sure you know the difference between NIR and EAR. NIR is offered by the state bank, which is under the monetary policy. If you study in future any subjects about banking and finance, then you will understand how we estimate NIR. So in this question, we will learn about EAR. But remember, if you want to calculate EAR, you need NIR, right? If no NIR, then you cannot calculate EAR. Of course, as I said, if you need to calculate this 11%, you must have 15%. If you don't have any information about 15%, how are you supposed to calculate this 11%, right? So you must have NIR to calculate EAR, all right? So NIR will be given in your questions. You don't have to worry how to calculate NIR, right? So let's move on to the calculation of EAR, right? So EAR. Okay, so the formula is EAR equals to 1 plus R divided by M. And here is also M minus 1. All right. Now, R, you know that. R is a rate, rate or nominal interest rate, same thing, which is given in your questions, right? Here, M is like as T. You can call it T or you can call it M, all right? So what M stands for? M basically indicate the number of compound, all right? Number of compounds. So this is M and this is M, this M, same, both are M, right? So this M indicates the number of compound. Now, what does it mean, number of compound? For example, if your question says you deposit money in bank with compound annually, if it says annually, you're gonna use 1. Annually means yearly, right? If your question says compound monthly, then you're gonna use 12. If it says semi-annually, then it will say 2, right? If your question says compound daily, it means daily means days. So in 1 year, we have like, let's say 365 days in a year, 65, 66. So just keep it simple, which is 65. Or if question says number of compounds or your investment compound weekly, then we're gonna write, question says weekly, then we're gonna write 52. In 1 year, let's say we have 52 weeks. So that's M stands for. So make sure you read your question when you have information given in your question, that your question says that interest rate is this, your cash flows are this. If your investment gonna you're gonna earn on your investment annually, monthly, weekly, yearly, then you're gonna use these kinds of numbers. So make sure you read your question carefully when you are calculating EAR, right? So same thing, that's also a number of compound. M also stands for number of compound. All right, so let's go to slide number PPT 59. So make sure you open your slides. So let me show you slides as well. Okay, here, slide number 59. Can you see that? Can you see the lecture slides? Okay. So that slide number is 59 here. So this is nominal annual rates, right? Or nominal interest rates. And second one is effective annual rate or effective interest rate. Right? So effective annual rates is the annual rate of interest actually paid or earned by borrower or lender. So in general, EAR is higher than nominal whenever compound occurs more than once a year. So remember that. EAR is a higher, as I said, is an actual interest rate, but it's compound. All right. Compound means interest over interest. This is called compound. So let me give example if you do not know what is compounds. So compounds means interest over interest. So let's say you deposit $100 in bank for 1 year. So you have a rate, right? Rate, and you have time. All right. So let's say rate is 10%. So after 1 year, it's gonna be 110. And then you 110 you deposit back in your bank account. So you're gonna calculate another 10%, which is 1 to 1. So this 1 to 1, meaning of 1 to 1 is a compound. Interest over interest, because your principal amounts is 100, your interest is 10, so that's why it's become 110, and now you are calculating 10% on your interest, which is involved in 110. So that's the meaning of compound, all right? Interest over interest, right? So if your number of compounds are increasing, number of compound means your T represents number of compound. Number of compound means time. T or M, same thing, right? If your M or T is increasing, your return is also increasing, because let's say you deposit money on compound monthly. So every month you're gonna receive interest over interest. So your investment gonna be increased by 12 times, because 12 months, right? So your investment gonna be increased by 12 times. As a result, your investment is frequently increasing. That's the meaning of EAR, right? Compound, that's the meaning of this sentence. That's the meaning of this, right? Okay, so let's take a look on a question. So here is a question: is Fred Moreno wishes to find the effective annual rate. Find EAR, all right? Find EAR associated with an 8% NAR, right? So NAR or NIR. So as I said, without this NIR or NAR, we cannot calculate EAR. So 8% is NAR, which is R, all right? When interest is compound annually, if your interest is compound annually, what is EAR? First question. Second question, if your interest, which is 8%, compound semi-annually, then what is EAR? And third, if your interest is compound quarterly, what is EAR? Which is this. All right? So the formula is 1 plus R divided by M. This is M. All right? Denominator is M. So 1 R is 8%. All right? First question is annually. Annually means 1. Yearly. So 1 year. So that's why M is 1. 1 and 1. So if you solve it, your EAR is 8%. EAR same as NIR. Why? Because NIR is a annual and EAR also annually. So in that case, both interest rate are same, 8%. But as we look in the previous slide, if your number of compound are increasing, then you're gonna earn higher in EAR compared to NIR or NAR, right? So have a look in the second So second, so this is 1, which is annually. Second is semi-annually. Semi-annually means M is 2. So M is 2 here. M 2, that's also 2, right? Rate is 8%. So if you solve it, you can see your EAR now 8%, because in first question your EAR was annual, now semi-annual, so which means compound 2 times. So that's why your interest rate is increased. You receive interest over interest, right? In the third question, it says quarterly. When M is 4, right? So you can see 4. M is 4. So EAR now become 8.24. As number of compounds are increasing, your EAR is increasing. Now, can you do me a favor? Can you tell me if your investment compound weekly, what is EAR? Can you calculate EAR if your investment compound weekly? How much? 8.32. Yes, that's right. 8.2, 8.33, sorry. 8.33%, right? So 8.33% is compound weekly, right? So if you calculate compound daily, can you calculate compound daily? Number 5, compound daily. Tell me your EAR, how much? So make sure in daily you are using 365, right? In the formula you're using 365. M is 365, right? Yes or no? Say something. M is 365. Yes, okay. Yeah, so if M is 365, your answer gonna be 8.33 or 8.327. So it's 8.327. So 8.327%. So we can use it maximum 2 decimals. So 8.33 is the daily. Okay, so this is the ideas about EAR, right? So this is the way that we are estimating EAR. So as you can see in all these examples, as your number of compounds are increasing, your EAR is increasing, right? So now let me give you a questions to practice your EAR. So let me find your questions for EAR. Yes, here is a question. So here is your question. Can you see the questions? Can you read it clearly? Yes or no? Say something. Okay, so here is your question. So the question is, you are looking at two saving accounts, right? So you have two saving accounts. One is, so let's say A pays 5.25% with daily compounds, all right? And the other pays 5.3% semi-annually compounds. Which accounts should you use, all right? Let's say A and B, all right? Which one you will choose, A or B, all right? And why, all right? So can you tell me which one you will choose, A or B, and why? Finished? A, why A? Reason? Why choose A? Reason to choose A? Yes, A is the right answer, but why A? So how many percent option A gives you? How many percent option A? Yes, A has more EAR than B. So A is a, I think A is a 5.39. Yes, 5.39 and 5.37. All right. So A is 5.39 and B is 5.37. It's easy to understand which investment choose. Of course, A choose because A compound daily, all right? So A gonna compound 35 times, all right? Whereas B, compound semi-annually, all right? So which means it's gonna compound 2 times, right? It's gonna compound 2 times. So by that reason, answer is A, but of course you have to explain why. So the reason is A gonna give us 5.39% and B gonna give us 5.37%. So if we're gonna make an investment in this option, we're gonna earn better. So by that reason, we choose investment A. All right. So this is the ideas for EAR. So let's move on to the that's all about interest rate. So interest rate is finished. All right. So we already finished cash flows. We finish interest rates. Right? So let's move on to the third one, which is special applications of time value. So we will do special application for time value. Then I'm gonna give you more questions for practice. So we do special application now, then we go for break. After break, when you come back from the break, and then we will practice questions about perpetuity, annuity, mixed stream, or single cash flow. So maybe some questions is about interest rate and some question is about time, which is special applications of time value. So let's move on to the next. So next is number 3. So number 3 is about time value. We call it special applications of time value. Special applications of time value. Okay, in this, so I repeat, this is about time value, right? So we may have to estimate our cash flows which based upon the time. We may not calculate interest rate, but we calculate maybe cash flows or maybe interest rates using a time period. We will not calculate the time period here. So let's start with the first applications about time value. So the first one is a here. How much cash flows required to have future value? What does it mean? It means, for example, you go to bank, right? And you ask bank, if you deposit some money, let's say if you deposit annually, if you deposit some money annually, how much we will find later. If you deposit this money annually, bank will give you 10% interest rates for 5 years, right? And after 5 years, your investment will be, let's say, I don't know, for example, $50,000. All right. So after 5 years, you need $50,000, and you go to bank and you ask bank how many percent rate of interest you're gonna give. Bank will say that 10% annually, right? And you need after 5 years. So now the question is how much you have to deposit annually. Remember, this question is different than the present value. In the present value questions, how much you need to have right now to have $50,000 after 10 years, after 5 years at 10%. But in this question, how much you have to deposit every year. So every year, 1, 2, 3, 4, 5. How much you need to deposit every year so your money will become $50,000. That's the question's about, right? So can you tell me how much you need every year? Of course, every year we have to deposit minimum, or we have to deposit 10,000, right? 10, 10, 10, 10. So every year we have to deposit 10,000. So to have $50,000. But that's not the correct answer. We need an exact number. So with the help of exact number, we can understand if you deposit this money, your total investment gonna be 50,000. So every year you're gonna deposit less than 10,000 because you're also gonna earn some interest. So can you tell me how much it will be? Any idea? How much it will be? Anybody, any idea? You said 31,046. So every year you have to deposit 31046, then 31046. That's what you mean. So it's gonna be way more than 50,000. Someone said 6209. No, 6209 is not the right answer. Okay, I'll tell you the right answer. Right answer is what I calculate, 9802. 9802. Every period, every year, you have to deposit 9802, this money, every year. With the rate of 10% for 5 years, your investment gonna be 50,000, right? So now the question is, how did I find this number? So there is a formula to estimate this number. So the formula is future value divided by 1 plus minus. Yeah. If you insert all this information, which is future value is 50,000 and its 1 plus rate is 10% or 1%. And that's T is 5 minus 1 and 0.01. Right? And if you solve it, you're gonna get same number, which is 9802. All right. So remember, this question is different than present value. All right. This question is different than present value. All right. In present value, we just find a one number. If I say how much you need to deposit right now to have $50,000 after 5 years at 10%, then we're gonna calculate present value, and you can find what is gonna be like. I don't know, it's like 37, 38, whatever present value you can find. But if this question says how many cash flows required, cash flows required means how many regular cash flows, right? Regular cash flows. This is regular cash flow required, right? To have $50,000. Right? So this is the ideas to estimate first one. Right? This is the special applications for time value. Right? So let's move on to the second one. Second special applications. Second special application. Second one is a loan amortization. Loan amortizations. Now, what does it mean, loan amortizations? For example, you go to bank. Of course, we are talking about loan, which means we are talking about borrowing money, right? We're talking about borrowings. So you go to bank to borrow money, and you want to borrow $10,000 for 5 years. You want to borrow $10,000 for 5 years, and bank charge 10% rate of interest, right? Now, I ask you, if you borrow $10,000 for 5 years at 10% rate, then how much how much you have to pay back regularly to return all money back with interest. So which means how much payback regularly. So which means how much cash flows you need every year to return $10,000 back to bank with 10% rate of interest. So means, can you tell me, you have to pay 5 times. So let's say you decided to return money back to bank every year, right? You borrow 10,000. So which means you need a 5 installments. You need a 5 installments. So you need 5 installments to return $10,000 back to bank with interest. With interest. So of course, it's not gonna be just 2,000. So it's 2,000 plus something. 2,000 plus something. So how much? Can you tell me? How much you have to return equal to return money back to bank? So regular installments you require. Three, 6, 3, 8, let me check. So the number, I got it. It's anybody else? Different number? How much we have to pay? Yep, that's right. 2, 6, 3, 8. Right. So we're gonna pay this money back regular, right? So regular cash flows. So this money we have to return back to bank periodically. So let me show you how we got this number. We have formula, which is present value multiply by rate divided by 1 minus 1 divided by 1 plus R T, right? So if you insert all this information, so present value is 10,000 because right now we are borrowing 10,000, so it's PV. Rate is 10%, all right? And same rate is 10% and time is 5. If you insert in your calculator this one, you got 2638. So means every year you have to return $2,638, so you can pay all money back to bank on time. So this is called loan amortization. So which means how many periodic payments required. So loan amortization means amortize means reduce, right? So loan redemptions. So how many NUT. Required for loan repayments. So remember, the difference between loan amortization and the first one, how much cash flow required to have future value. So the difference between this 1 and 2 is, in loan amortization, you are borrowing money, right? So you have a cash inflows, right, at initial level. And in the first, this one, the first special applications, you have a cash outflow at initial level. So it means you are making investment. So you are lending. If you're lending, how much you're gonna earn regularly. And if you are borrowing, how much you have to pay. So that's the difference between 1 and 2. So they are different from each other's, right? So let's move on to the next. So number 3, special applications. And that's also 3. Right. So third is finding interest rates. Finding interest rates. Finding interest rate, you have, so finding interest rate means you have future values, you have present values, and you have a time. So we need to calculate rate of interest. So let's say right now you have $10,000. After 5 years, that let's say $10,000 will become $20,000, right? So present value, $10,000, all right? After 5 years. So this $10,000 will become, let's say, $20,000, all right? So the idea is how much rate of interest you need if your 10,000 become 20,000 in 5 years. Tell me. How much? So we need 14.87%, right? So how we got this one? So we have a formula, which is future value divided by present value, 1 minus n. N means time, minus 1. N means t. You can call it t, you can call it n, whatever you like it. So future value 20,000, present value 10,000, n is 5. So 1 divided by 5 minus 1, if you solve it, you will get 14.87%. Right? So this is the special applications for finding an interest rate, right? So now so something I'm going to teach you now. This is the so this is the last last point for this topic, topic 3. So let's move on to this point. the fourth one, the fourth special applications related to time value. So the fourth one is finding number of period. Finding number of period means you have present value, you have future value, and you have rate. So now you have to find T, right? So we can take the same example that we took it before. So let's say present value is 10,000, right? Future value is 20,000. Rate of interest is 14 point, let's say 86%. So now the question is, if you want to earn 20,000 and right now you have 10,000 and the investment is offering you 14.86% return. So how long it required to convert 10 into 20 at 14.86%? If you solve it, it's gonna be nearly 5 years, right? But the question is how we got this 5 years, right? So we have a formula. Formula is in future value divided by present value divided by in 1 plus R. So this in, you can find, this is login that you can find in your calculator. So there is options for in. Here is the right corners, right? So here, I don't know, you can see or not. So I guess you can. So here in, you can see this one in. So if you use this in, insert this information, then you will get the same answer. So let's check whether it's a 5 years or something else. Have you got it? Did you try? Yes, so it's nearly 5 years. So let me change this question so you can quickly calculate it. So for example, your future value, you want to earn $50,000, right? And right now you have, let's say, $25,000, and bank is offering you 25% return. So how long it's required? Calculate. All right, so tell me how long it's required. Yes, so it's required 3 years, right? So we need 3 years to convert this 25K into 50K at 25%, right? So that's the ideas for your special applications, right? So special applications is finished. So all the informations related to topic 3, which is financial mathematics, it's finished, all right? So anybody has any question? Any question? Yes or no? So if no questions, then we go for short break, and after break we will do some practice questions regarding perpetuity, NUT, maybe EAR, or maybe special applications. All right. So we go for break, and then I'll see you after a short time. Okay, so this is the question. So make sure you note down these questions, because this type of question, you're gonna most likely to see in your exams. So please calculate and tell me how much is that. Okay, so everybody finished? So let's check what will be the cash flows for the present. So we can simply 4 years, 0, 1, 2, 3, 4. Right? So first year 200, 400, 600, and 800. Right? So we need to calculate PV. Right? So we're gonna calculate PV for all these kinds of cash flows, and we're gonna add them all. So the answer is someone give me answer which is I don't know how much answer you give me. Someone give me answer 2,525, which is not correct. 2523 is not correct. Yes, 1432.93 is correct. Right? This number is correct. So how you got this number? So you got 178.57, 318.88, 427.07, and 508.41. So this present value for 200, this present value for 400, this present value for 600, and this present value for 800. So if you add them all, that's gonna be equals to 1432.93. All right? Yes or no? Is it okay? Say something, yes or no? So remember, T is one year, 2 years, 3 years, and 4 years. So this is your T, all right? So following this T, if you estimate one by one, you will get all these numbers, right? So is it okay? So can we move on to the next? Okay. So here is your next question. So here is your questions that you are considering an investment that will pay you $1,000 in 1 year, $2,000 in 2 years, and $3,000 in 3 years. If you want to earn 10% on your money, how much you will be willing to pay? So how much is your present value? So calculate and tell me how much. For $2,000 investment, PV is 1652.89. And for $3,000 investment, PV is 2253.94. If you add them all, that will be equals to 4 4815. Right? So that is your answer, 4815. So this is the PV and this is your cash flows. All right. Yes or no? So can we move on to the next? So make sure you remember these type of questions. You write down, you note down. That's questions more likely to see in your exams. So let's move on to the next. Okay. So next. So here is your questions. So it says that suppose you are looking at following possible cash flows. Year one cash flows 1,000, year two and three cash flows 200, sorry, 100 for year one, year two and three 200, 200, year four and five 300 and 300. The required discount rate is 7%. So now you have three questions here, right? So let's say A, what is the value of cash flows at year five? B, what is the value of cash flows today? And C, what is the value of cash flows at year three? So tell me, calculate and give me A, B, and C. Okay, so now I'll show you how we get all these three numbers. So let's start with the A, which is calculate the value of cash flow. So let me write down the cash flows. So cash flows are 100, 200, year 2 and 3, 200, 2 and 3, 200, 4 and 5, 300, 300, 300, and yes, only 5. 1, 2, 3, 4, and 5. So if you calculate future value of all these numbers, so future value for 100 gonna be 131, and future value for 200 gonna be 245. This 200 gonna be 228.9 or 229, and this 300 is 321, and this 300 is 300 because third year investment is made at the end of the year, we assume. So that's why fifth year cash flows will have 0 return. So if you add them all, it's gonna be 1, 2, 2, 6, right? This is gonna be 1, 2 to 6.9 maybe. So approximately 1, 2 to 6. So this is about A. So let's have a look about B. B is what is the value of cash flows today. So of course we're going to calculate the present value of all these cash flows, right? So present value of 100 will be 93.46, then 174.69. This is for second year cash flows, which is 200. Third year cash flows present value is 163.26. Fourth year is 228.87, and fifth year is 213.90. Right. So if you add them all, it's gonna be 874.18. Right. So that is the present value for B. Let's talk about C. For C, it says that what is the value of cash flow at year 3? So year 3. So let's say 1, 2, 3, 4, 5. Right. So question is, what is the value of cash flows at year 3? So here what we're gonna do, how much is the cash flows total here? So what we're gonna do, we're gonna calculate PV and PV, right? FV and FV, right? So, and then you're gonna add this number. If you solve it, so right. So if you're gonna solve it, so what cash flows we have? We have 100, 200, 200, 300, and 300. So future value of 100, future value of 200, that will be same, which is 200, present value of 300 and 300. So what will be the number? That's gonna be 114, 214, 200, which is of course third year, right? And 280 and 262, 262, right? So you're gonna calculate future value, present value of 300 and 300, we're gonna be 262 and 280, and we're gonna calculate FV, all right? We're gonna PV, and that's gonna be same. So if you add them all, so that's gonna be equals to 1071, is approximately that number. All right, so this is the way to estimating, this is the way to estimating the present value, future value, and for year C, which is present and future. Most of students, when they calculate C, they made a mistake. What they do, they think about like this. They think 1, 2, 2, and 3. They think we have to calculate up to just 3 years, right? They think like this, but actually that's not, because we have a cash flows for year 1 to 5. If something is 3, so here and here. So that's gonna be your answer. So this is the way to estimating the cash flows for a given number. All right, so is it okay? Can we move on to the next question? Yes or no? Okay, so let's move on to the next practice question. So this question is about annuity, right? Okay. Okay. Here's your questions. It says that this is about annuities. I'm telling in advance so you don't have to worry that is it compound or annuity. So it's quite simple. So you have to find the cash flows using annuity. Right? So after carefully going over your budgets, you have determined you can afford to pay 632 per month. So every month you are paying, so which is fixed periodic payment. So that's known as annuity. So $632 per month towards a new sports car. You call up your local bank and find out that the going rate, which is rate of interest, is 1% per month for 48 months, right? So per month for 48 months. So how much you can borrow? So calculate using cash flows, calculate annuity. So how much you can borrow? Yes, how much you can borrow? Yes, you have to calculate how much you can borrow. So you can apply ordinary annuity. We assume at the end of the month. All right. So you can calculate using ordinary annuity. So let me make it clear. So it's gonna be easier for you. Ordinary annuity. So at the end of the, which is at the end. 24,000? No, that's not true. No, that's not. Oh, sorry, that's right. I'm sorry. It's 24,000 is correct. So I misunderstood. Yes, that's right. So right answer is 24,000. All right, so it's right. Both answers are correct. So let me show you how we got these number. Right. So yes, 24,000 is the right answers. So how we calculate? So we're gonna apply ordinary annuity formulas for future value. All right. So the formula is cash flows. So cash flows are 632. So 1 minus 1 divided by 1 plus 1% is equals to 1.01. All right. And time period is 48 divided by rate, which is 1%. All right. And that's all. If you solve these equations, so it's going to be 24,000. All right. So if you, this is about future value. All right. For ordinary annuity. All right. If it's annuity due, then what you have to do, 24,000, 1 plus R is going to be annuity due. So whatever. So it's 24 something. So this is annuity due. Not much difference, because since our rate is just 0.01%. So that's your rate. So in the due and ordinary, not gonna have a much difference, right? So yes, the right answer is 24,000 for ordinary annuity or annuity due, whatever, right? So is it okay? So can we move on to the next? Move on to the next. Okay. Let me check. Okay, so here is the questions. So this is your questions, which says that suppose you borrow $25,000 from your parents to buy a car. You agree to pay 207.58 per month for 60 months. So what is a monthly interest rate? Can you calculate interest rates monthly? Which means you have to calculate R. All right, you need to calculate R. Yes, finding interest rate. So this is about finding interest rate. Finding interest rate. Money paid per month is 207.58. So let me show you. It's can you see that 207.58? Okay, so tell me how much I need to pay. Tell me how much finished. How much is 8.31? Yes, that's right. 8.312. So 8.31%. Right, how we got this one? We apply the formulas, 25,000 divided by cash flows, which is to a 7.58. 1 divided by n, which is 60 minus 1. All right. So if you solve it, you're going to get this rate, which is 8.31%. All right. So that's all about this topic. So we nearly cover all the questions, practice questions. All right. So now topic 3 is finished. Right. So now I'll see you. So let me check again the schedule. Wednesday. Wednesday.